Hey, what's up, degenerates?
Today, I'm just going to give a quick explanation behind Honkai Star Rail's lottery thingy so that you can understand which choice to pick. But let's be real, you guys are still going to gamble because all of you are fucking addicts. So let's explain the math. To first understand how all of these statistics work, you have to grasp the concept of independence. To further illustrate what the definition is trying to say, using flipping coins as an example, if I were to flip a coin 2 times in a row, the results of each coin flip will not affect the other. As in, if I were to roll heads on the first flip, the second flip, the probability of getting heads would still be a 50% chance. As you can see from the slide, likewise, it's pretty similar for independent events. But why is that important? We can calculate the probability of two independent events occurring simultaneously by just taking the product of their individual probabilities. Assuming both events are independent, the probability of me smashing Tohru is 50% and the probability of me destroying kids in Roblox is 90%. So if I want to calculate the probability of me being able to do both, I just have to take 90% times 50%, which will give me 45%. This is why independence is important because if the events are not independent, you cannot calculate their probability like this. Oh, but what the fuck does this matter, man? When are you gonna start talking about boobs and shit? Yo, shut the fuck up. Wait, I'll get right into it. Oh, I just fucked up my slides. Oh, fuck. Wait, what the fucking... Oh my god.
Yo, this is
But
future
you might
me.
be
I'm just
asking,
gonna redo this
"Hey,
part
but
because I
Sonja, your
explained it in
YouTube
such a
shorts just use
fucking
the
dumbass way
expected result formula
and I
for
basically
dissipating random
overcomplicated
variables
things.
and prove that..."
So, what I was trying to say here is that there was some YouTube shorts that's using this formula to show why you should actually gamble because the expected results is more than if you don't gamble. However, this formula isn't that reliable because we only roll 7 times.
I'm just gonna play a video of myself explaining this shit, so if we choose not to gamble, the
The gems we
probability
get.
would be 100 times 7, which will be equals to 700. And in order to get more than this 700, we have to hit the first prize at least once, which will give us a minimum of 600 plus 6 times 50, which will give us 900. And the probability of hit is times 6 because one of the usages has been used up to win this, by the way. Now, you might be asking, how do we calculate the probability of us hitting the first prize at least once? Isn't there too many scenarios to consider since we can hit it from 0 to 7 times? There's 6 different scenarios in which we hit the first prize at least once. However, there is one scenario where we do not hit it at all. Therefore, we can just calculate this probability and we can take 100. But I meant there's 7 scenarios, I counted wrongly. Shut the fuck up. But minus the answer of this to get the probability of us hitting it at least once. But to further explain whatever rubbish I was trying to explain, instead of calculating the probability of success, which is the many different scenarios where we actually won the 600 gems, we are just calculating the probability where we didn't. Since we either succeed or fail, the probability of success plus the probability of failure will be equals to 100%. That's why we can just take 100% minus the probability of failure. So I define over here what success and failure is for simpler working, and I've also taken the liberty of converting percentages into fractions because I'm too lazy to type out the percentage symbol over and over again. And by the way, for you dumbasses, this is just 0.9 times 0.97 times. And the final answer would be, oh, went too far, oops, 52.2. In conclusion, this is the probability of obtaining more gems from gambling compared to if you don't gamble.
Wait a
But
second.
why do you keep talking
But
about
what was that
trials
part about the
just now,
trials?
bro?
What was that
What
for?
are you even on about?
The reason why I was talking about independent trials at the start is because you need them to be able to define this scenario as a binomial distribution to make calculations easier if you are using a graphing calculator.
And if you want to type this into a graphing calculator, we can actually calculate the probabilities instantly using the binomial CDF and binomial PDF command. Since it's already 7 a.m., I'm too lazy to go more in depth, and I doubt anyone cares. If you want a more detailed explanation, I'm not gonna do one.
X actually means different things for binomial PDF and binomial CDF. And you can read what the differences are right now. Also, notice how I use 0.9 as the probability P, which is also the probability of obtaining 50 gems in one draw. Therefore, the final answer for both the binomial PDF and CDF are in terms of the probability of drawing 50 gems.
Now, I know all of you are lazy, so I've just calculated everything out and put it into a spreadsheet.
It's technically a table, but fuck you.
You can just screenshot this and pretend you did it yourself.
But do you know why even if the odds are favoring you and you feel like the fucking chosen one, you should not gamble?
Take a look at this percentage again.
Is this not basically a fucking 50-50? When's the last time you've won your 50-50? Exactly. Good night.